Hello class, as I told you earlier through the announcements, labs are going to be a little bit different now. They're all going to be online, which means that you will have to do them on your own. In order for you to do them on your own, I'd like to give you a little bit of instruction, a little bit of help, because they're not as straightforward as if you were in the lab with your classmates and with me to answer those questions. So first of all, I'd like to take you to where it is that you can find those labs and where it is that you can find my help. So if you go to either the physical geology or physical geology lab links, in there in physical geology lab or physical geology by itself, if you go on to student mode, I put a tool, it's called Blackboard Collaborate Ultra, right here. So if you get into that tool, if you click on that link, you'll be able to see the different office hours and answers to questions times that I have. So if, for example, we open up that file, we see that I have time to help you out to answer those questions that you may have either from lab or from any quizzes that we took or whatever it is during the normal class time or normal lab time, as well as my usual office hours, which again are Wednesdays from 8:30 to 11:30. Okay? So if you want to talk to me directly via video, we can do so through this tool, okay? So that's how you get to it, Blackboard Collaborate Ultra. This is on the physical geology. Again, it's going to be a tool right below over here. And then if you go on to the lab shell, well, it's not letting me go into student mode, but you will see a similar setup for yours. You go below and you will also find it right below the discussion boards tool that I also made. So again, same idea. You'll see two different folders. One is my answers to questions and then the other one is my office hours times. Okay? Alright, so with that, all of the lab component of the remainder of the class is going to be under the lab shell in Blackboard, which means that you will not be going to physical geology for the content, but you will be going to the physical geology lab shell for the content. So click on that, and then all of the content for lab will appear under topic modules, Spring 20. So within there, you can see all the stuff we have already done. Before for lab, we didn't really use any of these, but now we are going to start using this. So you'll see that above the rock and mineral quiz, there's a geologic time chapter 18 link, which is going to be the first lab that we're going to cover together again online. So if you click on that, you can't right now because you can't see it, but you will once spring break is over. You will have several things. So you will have instructions for completing the geologic time lab. That will be what I'm doing right now. So you will watch this video, which will be linked right here, in there I tell you that I explain how it is that you're going to do the lab, which parts of the lab you're going to do, how you're going to submit the lab, and when I'm going to grade it, basically. And I also tell you that for this particular lab, you have an extra credit option, so I'll take you through that later in the video as well. Okay, so instructions are the first thing. Then below that, you will have the link to submit the lab, okay? So once you have completed the lab on your own, on your book, the questions or the answers to each question, you will basically input them through this quiz. So we'll come back to this quiz after I've taken you through how it is that you do the lab on your own. But remember that this is where you're going to find the way to submit said quiz, okay? Below that, there's the quiz for the extra credit lab option, as well as a link to another piece of information that I need from the extra credit lab. And as always, I have my lecture videos linked as well, in case you need to go through any of the material that we went through in lecture. Okay. So let's go ahead and look at the lab itself. Alright, so in your lab manual, the geologic time lab starts on page 83. This page that you're looking at should be page 85. So this beginning page and the following one just kind of take you through the principles and the unconformities that we should have already covered in class. But you can go through it, read again, since it's been a little bit of time since you saw this. So this first part of the whole lab is going to be on relative dating. So you go through the principle of superposition, principle of original horizontality, the principle of lateral continuity, the principle of cross-cutting relations. And then here Andrew doesn't cover the principle of inclusions, but make sure that you remember what it is. Again, principle of inclusions, because you will need it through the exercises that we'll see in the next few pages. Later on, he also talks about the 3 different types of unconformities. Again, remember that an unconformity represents a time of erosion or non-deposition that occurred, and then it's followed by renewed deposition. Okay, so unconformities, again, are a particular interest because they represent the omission of data from the geological record. So there are 3 different types of unconformities, as we saw in lecture. The first one is a disconformity, where you have horizontally sedimentary layers laying below the unconformity and horizontal sedimentary layers laying above the unconformity. The second type is a nonconformity. So a nonconformity is where you have an igneous or a metamorphic body that then got eroded, or there was non-deposition after it, and then following that time there was redeposition of sedimentary horizontally laying rocks, as you're seeing over here. And then lastly, the last unconformity is angular unconformity. So an angular unconformity is where you have tilted or folded layers beneath the unconformity, and then above it you have horizontally sedimentary rock layers. Okay, so with that, in here Andrew takes you through the next page in which we're going to practice these principles. What I'm going to do for this page is basically tell you the answers to it fully, and you won't have to submit these answers to me. Okay, so let's do this together, and then we'll go through some of the different diagrams that you'll be looking at on your own. Okay, so this is not how your page looks. This is a different setup, but it's the same information. So let's go through this first diagram. So in the diagram above, which were the first 3 units to form? So what do you guys think? Hopefully you're applying the principles of superposition here. So in this case, the first 3 first units to form should have been C, G, and E, right? Good, that was fairly straightforward. Then it says, these rocks were originally deposited as laying flat. That's the principle of original horizontality. What has happened to them? So obviously C, G, and E are no longer flat, but rather they have been folded. So that's what we should answer. So they have undergone folding. Then it says, what event is represented by the feature labeled J? Okay, so let's find it in the diagram. J is right here, and it's pointing towards this bolded black line, kind of squiggly line. So in that case, that's how all diagrams are going to represent an unconformity. So that's what you should answer, so unconformity. And if you wanted to be specific, what type of unconformity it is, hopefully you are thinking that that the layers underneath are folded or tilted, and right above it there's just horizontally sedimentary rock layers. So this is an angular unconformity. Cool. Okay. Then we have, using the blanks from oldest to youngest, fill out the order of the remaining units of end events. Okay. So we already said C, G, E. Now we have what came after E. What do you think? Could it have been H? Sure, it could have been, but H is also cutting through A and B. So H must be older than A and B. Could it have been J? Hopefully you're thinking that it was, right? J is the unconformity that is laying above E and G in this case, and it seems to be right below A. So J would be next, A would be next, then after A we have B. After B, would we have H or would we have D? So hopefully you're thinking we would have H. So H is cutting through A and through B, not through K, so H is younger than K, and it is not cutting through D. D is in fact cutting through H. So using the principle of cross-cutting relations, we know that D must be younger than H. So after B we have H, and then after H we have what? D or K? So in this case is D. K is actually on top of D, it's cutting through D. So D would be after H. Then we would have K. And then lastly we would have F. So there's not an existing blank because I did this in disorder. I think they would have, or you should have assumed that J had already been answered. So in fact, this should have been A, B, H, D, K, and F, okay? But you get the idea. Okay, good. So that was fairly straightforward. Here he also tells you that notice that the intrusive unit D shows a zone of contact metamorphism. So if you look at D, you see that there's a little bit of a kind of halo around the whole unit, a little bit of a shadow, if you would. So that is the zone of contact metamorphism that he's referring to. And I think he's pointing this out because in the coming diagrams you will have to use this contact zone in order to determine whether it is younger or older than some of the other units. Okay? So again, if, for example, the contact zone was touching A but it wasn't touching B, although it is, then you would maybe think that B didn't get, or the intrusion was somehow older than B. But that wouldn't also work with this diagram. But I think you are getting the idea. Okay. So lastly, remember that these diagrams are much, much easier if you work from oldest to youngest. So that's the way that we're going to go about it, okay? Okay, so I'm going to take you through this first diagram. There are 4 that you must complete. In all of them, you do have to submit answers on Blackboard for all 4 of them, okay? But I'm going to basically give you all the answers to the first diagram, and we're going to do it together. The following 3 you'll have to do on your own and get the answers onto Blackboard and submit them. And I'll tell you how in a second. So, okay, so let's see. Andrew did point out that it was easier to do this from oldest to youngest, so I'll try to do that through this medium. We'll see. Okay, so what do you think is the oldest unit? So let's see. So hopefully you're thinking E. In this case, L is representing the fault. So E should be the oldest unit that we have. Then let's see, how are we going to do this? After E we have J. Well, we'll make this work. After J we have O. After O we seem to have M. After M we have X. After X we have, what would it be? Would it be L or would it be Z? So hopefully you're thinking it would be L, as L is cutting through all of them, but Z is not just, I guess, on top of all of them, but it's also on top of L. So L would be first, and then Z would come after that. So now you may be thinking, okay, where does B come into all of this? B is cutting through all of those guys. But you notice that B is also cutting through the layers that are above it, so B doesn't come in for a long time after that.